Hello, algebra peeps. Welcome to our first weird, goofy lesson. I'm starting off with something I hope that you find easy. And tomorrow we're going to follow with something online. But hopefully this is an easy start for you. Okay, so we're going to be solving quadratic equations, which you're already familiar with. But this time we're going to be solving quadratic equations by the method of taking square roots. Okay, so let's get started. This first example, x squared equals 25, I just want you to think of what number squared equals 25. If you were all sitting in front of me, I think you'd all yell out 5. And that is true. But what other number squared would give you 25? Well, the answer is -5. -5 times -5 is also 25 because remember, two negatives, when you're multiplying, two negatives make a positive. So -5 times -5 is also 25. So when you answer these questions, to solve them directly, what number squared is 25? To undo the square, we square root both sides. Square root. The square and square root undo each other, and x is equal to, the square root of 25 we'll write is plus or minus 5. What I want you to remember is, for a quadratic equation, you usually have two answers. Okay, so that was an easy start. This one's pretty similar. Think again, what number squared would give you 36? And hopefully you can see that it's just 6 or -6. Again, the process, square root both sides, square and square root, they undo each other, so you get x equals, and over here you gotta remember it's plus or minus 6, which some people would write that as two answers separately, 6 and -6 are the two answers. But these are both okay to write them like that. All right, now let's step it up. Don't forget, when you square root both sides, you have two answers, okay? All right, so the next one, I want you to think about this one. What number squared would give me -4? Some of you are probably thinking -2, but -2 times another -2 would give you +4. So that didn't work. So is there a number that you could square and get a negative answer? And hopefully you can see that this one has no solution. Some people write it like this, which means no solution. Or you can just write out no solution. You're going to learn later that it might be better to say no real solution. There's no number in my calculator that I could square and get -4. So when you go to square root both sides, you cannot take the square root of a negative number. If this is a negative number, then there's no solution. All right, now the next example is the same idea. Refer back to our first one. I had x squared equal 25. You guys pretty much figured out that x equals plus or minus 5 because 5 squared is 25 and -5 squared is 25. Well, hopefully you can see that to get what number squared is going to equal 27, hopefully you can see that that's a decimal. Really close to 5, it's probably like 5.1 or something like that in my calculator. But bringing you back to the past, we're going to write our answer instead of the decimal answer. We're going to write our answer as a simplified radical. So we start the same. To get rid of this square, we're going to square root both sides, and x will equal plus or minus the square root of 27. If I were to put it in my calculator, I would put the square root of 27 in my calculator, and I would write that my two answers are plus or minus 5.1-ish. The simplified radical way, to bring you back to what we've done before, we're going to change 27 into two numbers that multiply to 27, but one of them is a perfect square. So what two numbers can you multiply together, but one of them you're able to square root? And hopefully you're thinking 9 times 3. Okay, then since I can do the square root of 9, I take it out of the radical. Okay, the square root of 9 is 3. The square root of 9, that comes out. The square root of 9 is 3, so it comes out of the radical and goes out here. So now my final answer is x equals plus or minus, there's a 3 outside of the radical and there's still a 3 under the radical. And this is how you write the exact answer. Again, if you put the square root of 27 into your calculator, it'll give you 5 point something. And if I put 3 root 3 into my calculator, it would also be 5 point something. Okay, so again, you'll do this when they ask for the exact answer. And it's anytime the number underneath the radical, if it can be broken down such that you can square root one of its factors. Okay, so pretty much that's the whole lesson. There's just gonna be a couple more steps for these next couple. All right, so this one, actually this next example is really just like the last one, no extra steps at all. Okay, let me get it situated. Okay, if x squared is 40, take the square root of both sides to undo the square, and x equals plus or minus. 40 is not a perfect square, so I'm just going to say it's the square root of 40. Now I have to think, are there two numbers that multiply to 40 where one of them I can square root? Okay, and hopefully you thought 4 times 10. 8 times 5 is also 40, but I can't square root either of those. So remember, we want to use only the perfect squares. So 4 times 10. And then again, the square root of 4 is 2, so it comes out of the radical. Cross that out. Square root of 4 is 2, it comes out here. And I get plus or minus. There's a 2 outside the radical. Under the radical, I still have a 10. Now you might think, wait, can't I still break up the 10? Well, 10 is 2 times 5, but I still can't square root either of those. Now, if you've forgotten your perfect squares, you may want to make a list of them because they're the ones that matter. You're looking for numbers that are perfect squares. So 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 25, 36. Make a list of them if you need to. Okay, keep in mind that this represents 2 answers, a positive 2 root 10 and a negative 2 root 10. So that's 2 answers. Leaving off the plus or minus is a big deal. Okay, last one is the one where I just add a little bit more work to it, but it's not more difficult at all. Okay, this just has more stuff going on. So whenever you see an x squared, but there isn't an x, it's just an x squared in that equation, then get the x squared by itself, just like you would if it was an x. So I'm going to first isolate the 3x squared by subtracting 5 on both sides, and you don't even really have to show this. You can kind of just do it. Bring down the 3x squared. Some of you like to draw a line where the equal sign is. You can do that, I don't care. So bring down the 3x squared, bring down the equal sign, and 17 minus 5 is 12. Get the x squared by itself. Divide both sides by 3. Again, you don't necessarily have to show that step. You can just do it. Now I have x squared is equal to 12 divided by 3, which is 4. Now this problem looks just like all the other ones. To undo the square, so they get just x, square root both sides, and x equals the square root of 4, and 4 is a perfect square. So the square root of 4, you should have said, hopefully, plus or minus 2. So there are 2 solutions, 2 and negative 2. Now, if you go back to the original problem and you check it, take 2, plug it in for x. 2 squared is 4. 4 times 3 is 12. 12 plus 5, yep, it does equal 17. Take the negative 2. Remember, when you square a negative number, it's always positive. Negative 2 squared is negative 2 times negative 2, which is 4. 4 times 3 is 12. And 12 plus 5, yep, it works. So those are your 2 solutions, okay? So